Hello students, today I am going to discuss about the usefulness of directional overcurrent relay for parallel feeder system or parallel transmission line. So for this I am going to use ETAP simulation. So first of all you have to double click on this ETAP icon, ETAP 12.610 icon. So this will give you this kind of window. So then go to file, open new project, click on new project. Next you have to choose your own folder there. I have already made one folder for our experiment, so I'm just going to choose this one. Click OK. Let's give the project name. Give one name there. This project name. Next you have to choose the unit system. Now unit system, it can be English unit system or metric system. For our experiment, I am going to take the metric system. Metric system, then click OK. Again click OK. So after that you get an open window. This kind of window. In this window, you have to draw the single line diagram for parallel feeder system. So for this parallel feeder system, so we need some basic components. First, we need a generator, bus bar, some transformer must be there, and we need some load. For this one, I'm going to take a static load. So first, click on this generator. Take it here. Now zoom this one. Zoom in this one for your convenience. Okay. So next, you have to choose the reference bus or swing bus. Slack bus. So this is the reference bus or swing bus, you can say. It is essential for load flow analysis. Next, you have to choose the transformer, two transformers for making this parallel transmission line or parallel feeder system. Like this. These are the two transformer 1 and transformer 2. Again, you have to choose the load bus. Another bus bar must be taken. It is called the load bus. Here the loads are connected. So I'm taking two static load. I'm taking two static loads. You can choose many more loads there, and you can also take 3 loads there. Okay. So next, first you have to click on this, double click on this generator. Now, after double clicking on this generator, first you have to choose the operation mode. Here I am going to choose this swing mode because we need a slack bus or swing bus there. So choose this swing mode operation. Then you have to take the ratings. So next you have to go this rating tab, impedance model tab, and inertia tab. So you have to take the basic parameters for this generator. So first click on this rating tab. Give the megawatt rating. So I'm taking 50 megawatt power at 11 kV voltage. So I'm choosing this two value 11 kV, 11 kV voltage and 50 megawatt power. Then go to the impedance model. In this impedance model, you can see all the impedances are initially 0. So you have to take the typical value. Okay, so click on this typical data tab, and this will give you the automatic value of this impedance. So it is automatically calculated. After that, go to inertia tab, and next you have to choose the inertia constant. Next you have to choose this inertia constant H. So for this one, I'm going to take 0.2. These are the initial constant 0.2. So I'm taking, these are the basic parameters for our generator. Then click OK. So double this generator now, it must be connected with swing bus or bus 1. Initially this bus bar voltage is 0, but if you connect this bus bar with this generator, now it automatically takes the voltage that is 11 kV. So as you can see here, it takes the 11 kV voltage automatically. Next, the primary of these two transformer must be connected with bus 1. So first double click on transformer 1, go to rating tab. So here you have to take the basic parameter, it is the rating tab and the impedance tab. So first click on the rating tab. Now primary voltage is automatically taken 11 kV because it is connected with 11 kV bus bar. Choose the secondary voltage 6.6 kV and MVA rating is taken, suppose 10 MVA transformer is taken. So click outside and this will give you the full load ampere. FLA full load ampere for primary and secondary. 525 for primary and 875 for secondary. So this is for the rating. Next, click on the impedance. Now initially you can see here the initially these impedances are 0. These all impedances are taken 0. So you have to take the typical value. You have to click on this 2 tab. So click on typical Z. It will take the impedance automatically. Then click on typical value. This will give you the no load test data. Okay. So these are the basic requirement for the transformer. So the other parameters. Next, secondary of the transformer must be connected with bus 2, and this bus 2 voltage it will be 6.6 kV now. Okay. It becomes 6.6 kV after that. Just joining the transformer. Next, you have to connect the static loads. Connecting these 3 static loads with bus 2, this load bus. Double click on the load number 1. Go to loading. Now, next you have to choose the loading. So for this one, I'm going to choose the kVA load. So first click on this MVA, it becomes kVA. I'm taking fast load is suppose 10 kVA. Click OK. Then double click on the second one. Go to loading again. Click on MVA. I'm taking 15 kVA for this. Then again click OK. Go to the third load. Go to loading again. Click on MVA. It becomes kVA now. Now here I'm taking suppose 12 kVA. 12 kVA load. Click OK. So all loads are connected now. So your single line diagram is complete. So next you have to run the load flow analysis and you have to check whether the all parameters are okay or not. So for this load flow analysis, you have to go to this tab first. This is the tab for load flow analysis. Just click on this. This will give you this kind of window. From here, you have to click on this briefcase and you have to choose the methods of load flow. First click on this briefcase. Here you can choose the method. Here I am going to choose the Newton-Raphson method for our application. Click OK. Then go to Run Load Flow tab on the right side. Now click on this. Next, you have to give some file name, output file name. I'm taking load flow for this. Click OK. And after that, you can see some fault is there. That is MV equals to 0. So some fault is there. What is the fault? Because in the second transformer, I am not taking the rating is taken MVA rating is not given. So I'm taking 10 MVA. Then go to impedance model. Take the typical value and typical Z. Click OK. Again run the load flow analysis. So next, this will give you the exact load flow analysis. And if you click on this alert view, the right side, this will give you that information that all the data are correct. All data are correct. So you don't have any kind of fault in the single line diagram. So next, go to the edit button. So after that, you have to connect the protective equipment. For this, first of all, you have to choose the overcurrent relay. This is the overcurrent relay and CT. So, and the high voltage circuit breaker from here. So first of all, choose the CT. Connect CT for line 1 and line 2. Next, take the overcurrent relay for line 1 and line 2. After that, take the high voltage circuit breaker for line A and line 2. And then you have to give the value of this parameter. So first, double click on this CT1. Go to rating. Now, transformer secondary voltage is 875. Do that. So this here is 875. You can check it from here. Go to rating. So full load ampere, you can see 875 here. So you have to take this value for CT primary. So this rating is 875 and secondary current is 5 ampere. Suppose 5 ampere. Click OK. Go to CT2, 875 and 5 ampere current. Same process. Then go to the circuit breaker 1 and go to rating. For circuit breaker rating, first of all, you have to choose the model, correct model of circuit breaker for this 6.6 kV rated kV system. Okay, first click on this library. From here, I'm taking Alstom model. I'm selecting rated kV 7.2 because our bus 2 voltage is 6.6 kV. So you have to consider a small value for this 7.2. You cannot take 362 or 25 like this. Okay, I'm taking 6.2 for this circuit. Next, go to this rated kV. You can change the rated kV and rated ampere for this circuit breaker from here. I'll take it 6.6 ampere, that is 875 full load ampere, 875, you know that. And you can choose the delay, 0.09, that is 90 millisecond. Next, click OK. After that, repeat the same process for circuit breaker 2. Repeat the same process for the circuit breaker 2. Alstom model, 7.2 rated kV, 6.6, 875. Here I'm taking the delay, that is 70 millisecond, 0.07 second, that is 70 millisecond. Click OK. So now circuit breaker is connected. So next you have to connect the overcurrent relay with the CT. So you know that for non-directional overcurrent relays, only CT is connected with the relay. So first double click on the first relay, go to OCR, go to this OCR, OCR, output and input. So first click on this OCR, you have to choose the model. For this one, I'm just going to choose Siemens model. Siemens model. Taking the second one. So this is a non-directional over current relay. Just click on this. We don't use I'm not taking this instantaneous operation. I'm taking just time delay operation. 5 ampere current is the rated current. Okay, so I'm selecting 5 ampere. Then after that, go to input. So in this input, you can see no voltage is, no PT is connected with this relay, but CTs are connected for phase and ground fault. CTs are connected as an input. Next, go to output tab and add. You have to flip the circuit breaker 1 for line 1. So click OK. So now circuit breaker 1 is connected with the relay. After that, repeat the same process for relay 2 in line 2. Go to OCR, select the model. Choose the same model I'm taking. Okay. Of the instantaneous operation, I have to switch off this instantaneous operation. Choose 5 ampere rated current or pickup current. Go to input. Now CTs are connected, CT2 are connected. Go to output. So you have to flip circuit breaker 2 for line 2. Okay, so go to add and choose ID is CB2 now. ID is CB2 now. Click OK. So everything is connected now. So this is a parallel feeder system, as you can see here. Now, after that, you have to make a fault and you have to check whether the relays are operating correctly or not. So first, go to start data coordination. Just click on this. Then go to this briefcase. Choose the sequence of operation from here. Take line to ground fault. Click OK. So I'm taking line to ground fault for the line 1. I'm taking this fault here. So you have to give one file name, that is fault. You can choose any other name also. Click OK. So now check whether these relays are operating correctly or not. So here you can see. Both relays are operating. What will be the direction of current flow? Current will flow like this. And for line 1 and for line 2, this current will flow like this. Okay, so here actually you need not to operate circuit breaker 2. You need not to operate this relay. Why? Because we have the fault in line 1 only. Okay, so you have to isolate only the line 1. And power can, healthy power, it can easily flow to the load. By this through this line 2. Okay, so you need not to flip this second circuit breaker CB2. Similarly, if we have the fault in the other line, what you can see, if we take the fault in the other line, then what will happen? Take this fault in the line 2. So you need not to operate circuit breaker 1. You need not to operate this circuit breaker, or you need not to shut down this line 1. Power can easily flow to the load, and you have to only isolate only the faulty portion. This is called the selectivity. This is called the better selectivity. So if we use non-directional overcurrent relay, you can see here it makes a total shutdown. Okay, so load will not get any supply from any line. But parallel feeder system is generally used for better continuity of supply. Okay, so you need not to keep the healthy line for this fault. Then what we can do now, instead of this non-directional overcurrent relay, we can use directional overcurrent. Now for this directional overcurrent relay, we need a reference, and generally for this case we consider voltage as a reference. So first, if we want a directional overcurrent relay, first of all you have to choose this PT. Okay, so click this PT, take to PT, here. So PT primary is connected with the bus 2, both cases, and PT secondary is connected with the relay. PT secondary is connected with the relay. So this picture, secondary is connected with this relay. Now, this relay model, it is basically non-directional overcurrent relay. So you have to choose a directional overcurrent relay. So first, double click on this relay, go to OCR and go to library again. From this library, you have to choose the directional overcurrent relay. So first click on this, then go to this Alstom model and taking this relay, this model of relay. So here you can see this directional overcurrent relay, the device number is 67. Now here we have 167 there, it is not selected now. Directional operation is not now selected. So this is one kind of directional overcurrent relay. Okay, so first of all, you have to switch off this instantaneous operation and switch on the directional operation. Okay, then click on this 67 tab for phase over current operation. So here we have direction, for which direction this relay should operate. Directional over current relay, it is generally used for reversed current flow. Okay, so this forward should not be taken. You have to take reverse. Okay, and maximum torque angle. So at which angle it produces maximum torque, that is called the maximum torque angle of this relay. And taking this 45, and voltage is the reference or polarizing quantity. Okay, so click OK now. This is for the phase over current relay. Next, go to ground. This is for earth fault operation. Again, repeat the same process. Click the directional operation. Click on 67. Take reverse. Focus on 45. Okay. Input. Now you can see here both CT and PT are connected with the relay. And output is now connected with circuit breaker CB1. Okay, output it is already connected with CB1. Then click OK. After that, click OK. And repeat same process for second relay. Relay 2. Click double click on relay 2. Go to OCR. I'm going to choose same model for this one. Alstom. This model. Switch off the instantaneous operation and click on the directional operation. Take 45 is the maximum torque angle and reverse action. Then go to ground again. Switch off the instantaneous operation. Then choose directional operation. Device number 67. Take reverse current or reverse direction. 45 is the maximum torque angle now. Okay, so these are selected. Here also input taken from CT and PT both, and output is now connected with CB2. After that, click OK. So Now the directional overcurrent relay is connected. So next you have to make the artificial fault from here. Take it here. Start coordination. Go to this briefcase. Choose the sequence of operation. I'm taking line to ground fault. Now create some LG fault in line 1 and see how this relay will operate. So now you can see only the CB1 circuit breaker is operating, and power it can easily flow through this healthy line 2. Okay, and here that bus bar voltage, it is not very low because some healthy current will pass to the healthy line. Only the faulty section is isolated by this circuit breaker and directional relay. Okay, so here you can see we are isolating only the faulty line, and healthy line is taking the load. Okay, and current will can easily flow through the healthy line. Now if we create the same fault line 2, in that case CB2 circuit breaker will operate. Only this circuit breaker and relay will operate because this is the faulty section. Okay, and healthy current, it can easily flow to the load by this healthy line 1. Okay, so this is the application of directional overcurrent relay. It has better selectivity. So in case of non-directional overcurrent relay, you can see all the relays and circuit breakers are tripping. Okay, but here that only the healthy sections are carrying the current. Healthy section are transmitting the current properly, but the faulty section is now isolated from the power system. So this is the application of directional overcurrent relay. This is the better. This is also called the better selectivity. This is our experiment, and that's all for today.